Now let us talk about the Boyle's law. Boyle's law, what does it say? The Boyle's law states that the volume of a given mass of gas is inversely proportional to the pressure, provided that temperature remains constant. Let me take that again. Boyle's law states that the volume of a given mass of a gas is inversely proportional to the pressure, provided that temperature remains constant. So what Boyle was trying to say is this, that if you increase the pressure on a gas, then the volume automatically reduces, or if you decrease the pressure, the volume increases. Boyle's law shows that there is an inverse relationship between the pressure and the volume of a gas at constant temperature. That is, the temperature does not change. There is an inverse relationship between the pressure and the volume of a gas. When we say an inverse relationship, what does that mean? An inverse relationship simply means that as one quantity is increasing, the other one is decreasing, or as the other quantity is increasing, the first one is decreasing. That's what we mean by an inverse relationship. So when you increase the pressure, the volume goes down, or when you decrease the pressure, the volume goes up. And this actually makes sense. This actually makes sense because if you are trying to compress your gas inside a gas cylinder, maybe you're cooking gas for instance, if you try to compress your gas inside your gas cylinder, what happens? By the time you increase the pressure on that gas, the volume of the gas will decrease. It means that the volume of the gas comes down. The gas itself gets compressed, and then they get compressed to a liquid, and then they get compressed to a smaller volume compared to when you didn't apply pressure. Do you understand that? So that is what Boyle's law is trying to say. Then mathematically, we can show a relationship between volume and pressure. Mathematically, V varies inversely as P. V varies inversely as P. This is the symbol for inverse variation. This symbol and then this one all over. It shows that we are dealing with inverse variation. So, and you know that whenever you are dealing with variation, you have to introduce a constant. So, by introducing a constant, we have V is equal to K times 1 over P. V is equal to K times 1 over P. Your V is the volume, your P is the pressure, while your K is the constant of proportionality. Don't forget that I didn't include temperature here because the T is considered to be constant. The temperature before you apply pressure and the temperature after you applied pressure is still the same thing. That's why we said at constant temperature. Then from this place, if I'm to go further with this, that will be V equals to K times 1 over V, which is K times 1 is still K. So I have V is equal to KV. And then if I decide to make K the subject of the formula, all I need to do is to cross multiply. When I cross multiply, I have my K is equal to PV. That is K equals to P times V, which is equal to what? PV. Now from this, it follows that your P1 V1 is equal to P2 V2. Since K is equal to PV, it means that your P1 V1 is equal to P2 V2, which is also the same thing as your P3 V3 equals to P4 V4. You can go on and on like that. But the basic formula that you should know for Boyle's law is this. P1 V1 equals P2 V2. This is the basic formula you must know for Ohm's law. P1 V1 is equal to P2 V2. What does all this letter, what do they stand for? Your K stands for the constant of proportionality, your P1 for the initial pressure, your P2 for the final pressure, your V1 for initial volume, your V2 for the final volume. So your P1 is the initial pressure acting on that gas. Then your P2 is the pressure you now applied to that gas. That's your P2. V1 is the initial volume of the gas. Then the V2 is the new volume of the gas. Then there's another way you can say Ohm's law. You can say conversely. Conversely means that, yeah, I started with volume, but here I'm going to start with pressure. It's still the same thing. I can say conversely, Boyle's law states that the pressure of a given mass of gas at a constant temperature is inversely proportional to the volume. So whether you say pressure is inversely proportional to the volume, or you say volume is inversely proportional to the pressure, we are still saying the same thing. We are saying the same thing because What matters is the temperature has to be constant. That's what matters. The temperature has to be constant, and then as you increase the pressure, you are decreasing the volume, or as you decrease the pressure, you are increasing the volume. So now, what is the pictorial representation of Boyle's law? Look at this diagram. Look at this diagram. In this diagram, I am showing you the relationship between pressure and volume. Pressure and volume. So pressure is on the upper side, volume is on the lower side. Now, what can we say about this diagram? One thing we can see about this diagram is that as the pressure is decreasing, gradually, what happens to the volume? The volume is increasing. As the pressure is decreasing, the volume is increasing. Or we can say it this way: as the pressure is increasing from right to left, as the pressure is increasing, the volume is decreasing. As the pressure is increasing, the volume is decreasing. Or you could say, as the pressure is decreasing from left to right, the volume is increasing. Whichever way you look at it, one is decreasing while the other is increasing, whichever way you look at it. So the diagram shows that as the pressure of the gas decreases, the volume increases. Similarly, as the pressure increases, the volume decreases. So this is about Boyle's law. In the next class, I will tell you about the graphical representation of Boyle's law, as well as some questions we are going to look at together concerning Boyle's law.